everyone, I hope you're all staying safe and healthy during this pandemic time, and I hope you're not too bored stuck at home. But if you're bored, I have a perfect science experiment for you. It's all about the equator, the sun, and how this affects temperature. So I want you to go ahead and start off by thinking of a few places that you know are warmer than your hometown. Okay, I think you probably got some. A few places that you may have thought of are Mexico, the Caribbean, Egypt. All these places are great answers, and there's so many other answers that you could have. One reason why all these places are so much warmer than Indiana is because of their position on the Earth relative to the equator. The equator is the imaginary line. You can't see it, but we all know it's there, and it divides the Earth into the north and the south. When you're looking at the sphere of the Earth, it is on the outermost point. I have a perfect experiment that's super easy that'll help you guys visualize this better. This right here is a picture of the equator. You can see how it splits the Earth into its north and south parts, and it goes along the sphere of the Earth so it hits at the outermost point. All you need for this experiment is a flashlight and a blank piece of paper. That's it. Two easy things that you probably have inside your homes already. In our experiment, we have our blank piece of paper that represents the Earth and our flashlight that represents the sun. To start, make sure you have batteries in your flashlight and you're able to turn it on. So first, we're going to point the flashlight straight down at the piece of paper. No angle or tilt or anything. The straight down represents the sun when it hits the Earth at its furthest out point. This is like when it hits the Earth at the equator. We can notice that when we're pointing the flashlight straight down, like the sun does on the equator, it makes a perfect circle. All the light is concentrated in this one area, and with the light, it will eventually get hot. If we go ahead and tilt our flashlight, this represents the sun when it's at other points on the Earth, not at the equator. We can see that the light spreads out and covers a further distance. When the light spreads out, so does the heat. So if our light and our sun and the heat from the sun is the most intense while it's at the equator and it's in this circular shape, what would happen if we tilted it this way? We could also tilt it this way. Do you notice anything? When it's straight up, it represents the sun at the equator and is a perfect circle only covering the space around the equator. But when we tilt it, what do you notice? Does it cover more or less space? You betcha, it covers more space. With the flashlight covering more space, it spreads out the heat and the energy across a bigger distance. If we have the same amount of energy and light here as we do here, but this one covers a bigger distance, do you think this is weaker or stronger? It's the same thing this way. Do you think the heat here is weaker or stronger? You're right, it's definitely weaker. If we have the same amount in a small space as we do a large space, the heat in the larger space is much weaker. This could help explain why temperatures are so much hotter in these places near the equator than they are in these places away from the equator. With just a simple piece of paper and a flashlight, we were able to figure out why the equator is so much warmer than these other parts of the Earth. You saw that when we pointed the flashlight straight down at the equator, the light was concentrated in just this area. This area would receive the most heat and it would be the most intense right here. But when we spread out the flashlight and we tilt it at an angle, like how the sun would be hitting these parts of the Earth because they're slanted, the light was spread out over these different parts. It was the same amount of light and heat that hit the equator, but it was over a bigger distance, making it less powerful and less strong. This helps to explain why places like
the North America, Indiana, where we're at right now, are receiving less intense light than places like Egypt and Mexico that are closer to the equator. Therefore, these places are much cooler and these are much warmer. I really hope you guys enjoyed this experiment and had a good time doing it. I also really hope you learned a little bit about the equator, the places near the equator, and why these places are so much warmer than other places on the globe. This is a great topic to talk about. You could tell your older siblings, younger siblings, your parents, guardians, whoever you want about it, and tell them all that you've learned while doing it.